So lastly, we need to talk about Gibbs free energy. And once I explain this to you, I will work on your own 13.11 in the next video, and then that will be the last video. So what does Gibbs free energy help us to figure out? It basically helps us predict whether a reaction can happen spontaneously or not. So first thing we need to understand is that entropy, the second law of thermodynamics, says that the entropy of the universe has to be greater than 0. So when I say that delta S is positive, that would mean increasing disorder. If delta S is negative, that would mean decreasing disorder. So if I'm trying to predict whether a reaction will happen spontaneously, if I have a negative delta H, which means it was exothermic, then I'm probably going to have a positive entropy, because the heat causes the disorder to increase. And likewise, if I have an endothermic reaction, it means I'm probably going to have a negative delta S, because the energy absorbed from the surroundings to make this reaction happen decreased the disorder. So understanding that, I can move forward to Gibbs free energy, and I can say, well, there are two ways that I can predict whether a reaction will move forward or not mathematically. I can use this formula, which is Gibbs free energy formula. It's delta G equals delta H, and I have to give this to you, minus T, which is temperature in Kelvin, times delta S. And I have to give you this too. So on your own works this equation, and I'll work it for you in a minute. This formula basically tells us if the reaction is consistent with the second law of thermodynamics or not. If I end up getting a negative G, it does mean that the reaction is spontaneous, because if delta G is less than 0, then that's a good indication that my reaction will be spontaneous. Look back up to here. These are the things I use in this formula. So if I have a negative H, a high one, and then I have a positive S, then I'm going to end up getting a negative number, because I've got a negative minus something, so I'm probably going to get a negative number, and that gives me a negative G. So that tells me that it will go spontaneously. Alternately, if I have a positive G from this equation, then my reaction probably cannot proceed, because it violates the second law of thermodynamics. So that would mean in this case, I should have put a delta there, that would mean that the delta G would be greater than 0 if it's a positive number. And that would mean that I probably had some sort of reaction that was endothermic. And because it was endothermic, it was decreasing in disorder. And because of all that, it can't happen spontaneously. Okay, so this formula is kind of a plug and chug formula. Now, the second formula that I use is this one. And it looks just like Hess's law, because it is. We've done Hess's law for enthalpy, Hess's law for entropy, and now Hess's law for Gibbs free energy, trying to figure out if it's going to run spontaneously or not. You would use this reaction, this formula, if they tell you that it was run at standard temperature. So standard temperature here is 298 Kelvin. So if they say a reaction is run at 298 Kelvin and they're asking you to predict spontaneity of the reaction, you would use this formula. And it's just the same. It's the products, and I look them up, I add them up and find the sum, that's what that means, on the table, and I subtract out the sum of the reactant. So again, I need to use table 13.4 for that one, okay? Now you do need to remember, and this is just plug and chug too, because you've already done 2 other types of problems just like this. You do need to remember that delta G is a state function, which means there's a certain Gibbs free energy calculated for it that is independent of the path of how it got there. And so any element or homonuclear diatomic would be 0. Okay, now I'll do on your own 13.11.